This is Josh White with JW Math Tutoring. In today's video, I'm going to cover Digital SAT Bluebook Practice Test 8, the Math section, Module 1. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Just before I begin going through the solutions to Digital SAT Bluebook Practice Test 8 Module 1, I want to mention a couple things that I mentioned at the start of each of these practice test reviews. First, obviously, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, this video will probably be longer than the time allotted to complete this module, and that's because I like to show as many methods as possible to solve these questions. So on some of them, I might show 3 or 4 different methods, but obviously if you're taking an official test, you don't need to do that. You know, maybe 2 methods at most, just you do the problem at once, and then maybe you go check it in Desmos just to confirm that you're correct. And third, if you haven't done so already, please do watch the solutions to Module 2A from this same practice test number 8, and Module 2B, the harder of the 2 second modules, to the same practice test 8, once both of those videos are posted. All right, so let's go ahead and get started with it now. Question number 1, Digital SAT Bluebook Practice Test 8, Math section. Here they just want the y-intercept of the graph. It's right here. It's just going to be the point 0, 8. So we can just select letter D and move on. Next up, we have a function. They want to know what the y value is when the x value is -8. So we can just plug in -8 and we get 24 plus 60, which is 84. Correct answer will be D. However, we can just also go to the Desmos graphing calculator and you could just type in the function, get the answer right there. Okay, 84, move on to the next problem. All right, number 3, here's one of these linear interpretation problems where they give you a situation and they ask you to come up with an equation that represents it. So obviously they're all equal to 70 because the total length of this video is 70 minutes, right? Okay, since x represents the number of 1-minute segments and y represents the number of 3-minute segments, basically x is going to be multiplied by 1, 1 minute times the number of 1-minute segments, and then y is going to be multiplied by 3. 3 minutes times the number of 3-minute segments, and together those minutes will add up to equal 70. So the correct answer for this problem is going to be letter D. All right, next up, question number 4. You are basically starting with 20 ounces of water, and it goes down by 1 ounce every 4 days. So if you're actually setting up an equation like this, it would look like this. And then the remaining water is 9 ounces. And you want to know how many days does it take for this to happen. So if you go ahead and solve this equation, negative x over 4 equals negative 11 times negative 4 times negative 4, x is going to be equal to 44. So the correct answer is, again, for the 4th straight problem, letter D. However, I would recommend, if you're not able to set up that equation, I mean, you can just back solve this. So you can basically just like go to the calculator. All right, so we're starting with 20. And then it says it's going to go down by 1 ounce every 4 days. So if you leave it uncovered, so start with answer choice A, for 3 days, then it will have gone down by not even 1 ounce. So it's not going to go from 20 to 9. So that doesn't even make sense. You can move on to B. Okay, again, 7 days is like one 4-day period, so it goes down by 1 ounce, but then it's not even a second 4-day period, so it doesn't even go down by 2 ounces. So again, that's not going to be equal to 9 ounces. Then for C, okay, what you would notice is, all right, 36 days and every 4 days it's an ounce, that would be it goes down by 9 ounces. So 20 minus 9, does that equal 9? No, it equals 11. So by process of elimination, it's got to be D. But then you could also go up here and check, and then you could say, oh, okay, it goes down by 11. 20 minus 11 is 9. So again, this is back solving without actually setting up the equation itself, plugging in the answer choices essentially. All right, here we have a dot plot, and it's asking us to compare the standard deviation values between these two dot plots. So I will tell you just right off the bat, the answer to this is B, problem number 5. The reason is because the distribution is identical. It's like 1 dot, 1 dot, 3 dots, 4 dots, 5 dots, 6 dots, 7 dots. Okay. It doesn't matter that the values are different. Like this one goes from 1 to 7, this one goes from 14 to 20. What you're looking at for standard deviation is how the values are distributed. Okay, and again, these each go in the same pattern of like a 1, 1, 3, 4, 5, 6, 7. So that's why the standard deviation is equal, and the correct answer is letter B. Next up, here you have just the basic, polynomial subtraction problem. So we combine our like terms, 7 minus 6, 1x cubed, 7x minus negative 3x, which is the same as 7x plus 3x, plus 10x. So the correct answer here is A. You could also, I won't go through the whole process, but if you wanted to, again, I wouldn't necessarily recommend that you do this for a problem like this because, again, I think it is much quicker if you know how to add, subtract polynomials. But you can also go through the process of typing out, what am I missing here? Oh, this should be X. There we go. The original expression, and then type out the answer choices, and you see which one overlaps it completely. Okay? So in this case, it is answer choice A. It overlaps with the original problem, therefore that's the correct answer. Next up, question number 7. So essentially what's going on here is in a triangle, you've got a 54-degree angle, you got a 90-degree angle, and then an angle which is k over 2, and that's equal to 180. So at this point, you can solve this equation, or if you didn't even set up this equation and solve it, basically this k over 2 is going to be 36 because these together are going to be 144, and then you subtract it. K is going to be 72. Correct answer is going to be C. But you could also, again, you could back solve this. So in other words, start with A, divide 36 by 2, 18, add up 54 plus 90 plus 18. Is that 180? No. Move on to B. Plug in B, 45 divided by 2, 22.5. Add that up. Does it add to 180? No. Move on to C. So you could also solve it that way as well. All right, next up, question number 8. What is a solution to this? Well, we have 3 of them. You have 3x equals 0, which gives us x equals 0. You have x minus 4 equals 0, which gives us x equals 4. And you have x plus 5 equals 0, which gives us x equals negative 5. So which of these do we see here? We see 0. I do not see negative 5. I do not see positive 4. So the one they're looking for in this problem is just going to be letter B. Also note, you could technically back solve this one as well. You could go through the answers, you could plug in A to this entire thing and see, do you get 0? And the answer is going to be no. And then you move on to B and you plug that in and you will get 0, and that's what the correct answer is. So you could also take that approach as well if you wanted to. Next up, number 9. So all that's happening in this problem is the wording of this is really confusing relative to how kind of actually simple and basic of a problem it is. Essentially what's happening is you're taking 10 mLs of acid and you're adding that to some unknown mLs of water. Okay, and together you get a mixture which is 56 mLs. So it's really just asking, but how much water did you add? Well, it's 46 mLs, and that's it. Again, the wording of this, if you read this, it is much more confusing than what's actually going on. You're just adding these two things together. 10 of one, 46 of the other makes 56 total. All right, question number 10. Just a basic unit conversion problem here. 354 furlongs. Let's get rid of that because that actually looks like feet. Yeah, furlongs. There we go. All right, and now we're going to convert eventually to feet, but first we have to go 1 furlong to 220 yards, and then 1 yard to 3 feet. So now yards cancel, furlongs cancel. So for this question, you're just going to multiply 354 times 220 times 3. So the correct answer for this is just going to be letter D. It's going to come out to 233,640. Next up, we have question number 11. We have a system equation, and they're just asking for how many points these intersect in the xy plane. So, a couple things. First, if you notice that these are parallel because they have the same slope, but they have different b or y-intercept values, i.e. parallel lines, then you know the answer is going to be 0. They will never intersect. Okay? However, if you don't recognize that, that's fine. Just go to Desmos, graph each of them out, and then you'll see that these two lines are parallel. Therefore, they will never intersect. So again, the correct answer for this one is just letter A. All right, next up, a percentage question. Basically, 13 is equal sign p% of multiplied 25. So, like, if you divide this now, sorry, not divide by p, divide by 25 on both sides. Okay, so here's the thing that's just a little tricky about this. Okay, if you divide these two, it comes out to 0.52. But that's the percentage expressed as a decimal. Whereas here, they're telling you that P is the actual percentage itself. So the actual answer that you fill in is not 0.52, it's 52 because it is 52%. Okay? Now, if we go to Desmos, and you type in something like this, 13 is, make that an equal sign, p% of 25. Okay, it's going to solve this equation. Actually, no, it's not because I got to use x instead of p. There we go. Now it solves it, and notice here it gives me the 52, the actual percentage value, not the decimal equivalent. Okay, so you can do this one also entirely in Desmos, in just one step and get the answer. All right, next up we have an exponential function. So this relates to something, the question basically that I talked about on Practice Test 7 Module 2A in terms of doubling time. And essentially, if you have an exponential function, okay, so you're talking about doubling time, that means you're going to have a 2 down here as your base. All right, and then you're going to have the variable up here in your exponent, and if this variable in your exponent is divided by a number, this is the doubling time value right here, whatever this number you're divided by is. Okay, so the correct answer for this is just 410. Now, if you weren't sure, you could essentially go to Desmos. And the problem is, though, yeah, see, the problem is you don't know exactly. Well, no, the problem is the numbers are so large. So let's do it this way. We're starting, first of all, I'm just going to pare this down to 60 instead of 60,000. So, and then what I'm going to do is I'm going to say, okay, here is my first function, all right, exponential function. Now I'm going to set it equal to double the amount. So for example, it's starting at 60. That's the initial amount. And I want to see, how long does it take till it reaches 120? 120 is double 60. So then I look for the intersection here and it's 410. Now the reason I made these 16120 instead of 60,000 and 120,000 is because then you have to zoom out a lot on the graph to find the values. Okay, but just reducing them proportionally, each by basically 1,000, doesn't change anything. Obviously the y-coordinate here it changes, but the point is the x value, the 410, what we're looking for, the doubling time, that part doesn't change. So that's how you could do this problem entirely in Desmos. Next up, we have a problem where they give you a description of growth of a function. They want to know which of these situations basically is it? Is it increasing or decreasing, exponential or linear? Okay, first of all, since it is increasing, it's not going to be decreasing. So A and B are out. So now the question is it exponential or linear? So it's going to be exponential. The correct answer here is C. And the reason is because it's increasing by a percentage, and more importantly, it's a percentage of its previous value. So in other words, what's happening is it's like it starts at x, and then you take 0.49% of x, which is the same as 0.0049 times x, okay? So you get 1.0049x. So it's like 1.0049 is basically your base. In other words, if you think about an exponential function, you have your initial amount, and then the 1.0049 is going to be the base here, and then it's raised to some, power or whatever. So this is how it's exponential. And what you could also do is you could start with, you go to the calculator in Desmos. Okay, so I'm going to say a equals 1. All right. No, I don't need the, there we go. There we go. Okay. So I start at 1 and I get 1.0049. Then I go ahead and I'm going to just add on to that. Okay, so what I'm going to do is basically look at it this way. It's like you start with 1, and then the output that you get is 1.0049. And then I'm going to take that, and I'm going to make that number my next input, because it says it increases by 0.49% of its value the previous year. So this now gives me a new value of 1.0098241. Okay, so if you look at these, y values, okay, it's obviously increasing, but is it increasing exponentially or linearly? Well, if it was linear, then the difference between here and here and here and here would be the same. But notice it's not. If you subtract these, okay, obviously this is 0.0049. But if you subtract the other one, so like here I have the 1.0098 blah blah blah. If I subtract from this 1.0049, notice the difference is not 0.0049. It's 0.00492401. So the point is it can't be linear. Linear is an increase of the same exact amount from one term to the next term to the next term to the next term and so on. Okay, so this just confirms, this is how you could basically use picking numbers to confirm that it has to be exponential and it cannot be linear. Next up, question number 15. Here we have a circle. We know its diameter endpoints, and they give us actually the standard form equation, but there's one part missing. What's the radius of it? So what they want you to do here to find the R value is basically take one of these points and plug it in. And let's see here. Yes, because these are endpoints on the circle. So 2 minus 2 squared plus 14 minus 9 squared equals R squared. This is 0. 14 minus 9 is 5, so 5 squared equals r squared, so r is just 5, or I mean, you can make this 25 if you want to, that's fine. So the correct answer is 5. I don't think that's the most intuitive or easiest way to solve it. Instead, what I would do is, honestly, I would just go to the graphing calculator in Desmos. I would type in, or no, I'm not going to type in the circle. I am going to, sorry, find the distance, that's right, between these two endpoints. That is your diameter, because it tells you these are the endpoints of a diameter. So to get your radius, you just take the total distance, divide it by 2. There's my radius, it's 5. Okay, so again, I use the distance formula on these 2 points. I divide that in half to go from a diameter to a radius, and I get 5. Same exact answer. Next up, question number 16. Here we have a right triangle. So we have our angle S here is, let's see, no, angle T is the 90-degree angle because it tells us R and S, the sum of them is 90. So they have to be the two acute angles. All right. So sine R, which is opposite over adjacent, is opposite root 15 over, or not adjacent, over hypotenuse. Sine R opposite over hypotenuse. So opposite root 15, hypotenuse is 4. What's the value of cosine S? So cosine S is just adjacent, which is also root 15, over hypotenuse, which is 4. So it's the exact same thing. When you have, and again, you technically don't even need to draw the triangle to set this up or to solve it. If you know that two complementary angles, i.e. two angles that add up to 90 degrees, the sine of one will equal the cosine of the other and vice versa. So the sine of r is equal to the cosine of s, which is also root 15 over 4, and the correct answer is letter B. Next up, we have question number 17. This one, we are basically solving a formula. And the easiest way to do this is to essentially just cross multiply. You know, like this is really over a 1, so you can cross multiply and you get 4j plus 9 times p, and that's just equal to k because you get k times 1. And then since you want to solve it for 4j plus 9, you can just go ahead and then divide by p. So final answer for this one is just going to be, let's see here, letter A. 4j plus 9 is equal to k over p. Now, you can solve these formula problems that have multiple letters in them by doing the Desmos calculator. I'm not going to demonstrate for this one because A, this is a relatively simple one, relatively basic one, really just 2 steps. And also B, the fact that they want you to solve for 4j plus 9. So instead of solving for just a single letter, you have to solve for an expression, which means that you would technically have to let this equal something else, like pick a different letter like U, and then you could go through and like solve it for U. So just because of that, I'm not going to demonstrate on this one. I would, basically only recommend taking that approach on more complicated questions that involve more steps. All right, next up we have a linear inequality, 2 variables. They want to know which of these, excuse me, which of these table of values are solutions to this inequality. So pretty easy. Let's just go to Desmos and actually, let me see here if I can. There we go. Now we can get all 4 answer choices on the screen. So first thing I'm going to do is just graph this, and then I'm going to start with answer choice. I'm going to start with answer choice A. I'm going to start with the first point, label it. Okay, so is it in the solution set? Well, the thing is, if you look here, it's right on the line, which means it is not in the solution set because this problem is strictly greater than. It is not greater than or equal to. So therefore, answer choice A is out. Let's move on to answer choice B now. So let's say I change this now to 326. Okay, so this one works so far. So let's check the next point, 542. Also, switch this up and label B. All right, let's zoom out here so I can get a better view. All right, so notice this is not in the solution set. So therefore, we found one point that does not work, cross it out or eliminate it. All right, let's next go back to answer choice C, try the first point. Jump back here, zoom out. Okay, is it in the solution set? No, it is not. So by process of elimination, we already know now that the answer for this is going to be letter D. 326, okay, we already checked that one in B, so we don't need to check that again. So let's check the 552, zoom way out, and then we can zoom back in and you can see, yes, it is in the solution set. And then lastly, 891. Again, you would not need to do this on the test because, we already know the first three are wrong, but just to prove that it is D and all 3 points work, there you can see the third point works as well. So the correct answer to this question, number 18, is just letter D. All right, next up, number 19. Here we have a line and you're told that another line is perpendicular to this. What's the slope of the perpendicular line? Oh, and let me snap back to the default zoom view. By the way, if you ever, all right, what's going on here? It should be, let's go to our shortcuts. Yeah, zoom back to 100% should be control plus 0. There we go. Not sure why I wasn't working before. But if you ever zoom in or zoom out and you want to get back to the default viewing size, it is control plus 0. All right. So the slope of this line, two ways we can get it. We can either, if you know the formula, since it's in standard form, it's negative a over b, which is negative 3 over 12, which would be negative 1/4. Or you could just put it into slope. Oh, wait a second. I made a mistake. Hopefully you caught it. This is not in standard form as it is written. We actually need to switch the order because A is positive 12 and B is positive 3. So let's switch these. The 12 goes up here, the 3 goes down here. So the slope of this line is negative 4. It is not negative 1/4. Alternately, you could put this into slope-intercept form. So you could subtract 12x and get 3y equals negative 12x plus 5, and then divide by 3. Y equals negative 4x plus 5/3. The y-intercept part doesn't matter. But notice we get the same slope here, right? Negative 4. So perpendicular lines have slopes that are opposite reciprocals. So negative 4 turns into positive 1/4. You could also write it as 0.25. So either one is acceptable, either 1/4 or decimal form 0.25. You could also write 0.25. That would also be accepted as correct as well. All right, question number 20. How many x-intercepts, does this graph have? So the correct answer to this question is letter B. It is 3. Basically, the 3 x-intercepts are going to happen at x equals d, x equals negative d, and x equals negative g. So you can confirm this, and the reason is because basically here we have a double root or repeat root. So even though there's 4 factors here, this x minus d that's listed twice, it's basically going to involve the graph bouncing or just touching the x-axis at that value. So if you wanted to just go to Desmos and confirm this, just pick some numbers. What I'm going to do is type in the whole thing exactly as written. Add some sliders, maybe make this, let's see, they have to be positive constants, so I'll make this 2, and they have to be unique, so I'll make this 5. All right, so now we have our graph, and we can see there are clearly 1, 2, 3 distinct x-intercepts. So this just confirms the correct answer to this one is letter B. All right, next up we have an exponential function, and they tell us f of 1 equals k, where k is a constant. So which of the following blah blah shows the value of k as a constant? So a couple things. First of all, theoretical approach. I already know, basically, I know that the answer is going to be C, because if you're plugging in 1 and you're getting some number, all right, as the answer, and you want that answer to show as a constant in the problem already, that means that when you plug in 1, you need the whole exponent part of the function to just essentially you need the exponent to be 0, which causes the whole exponent part or the base raised to the exponent to turn into 1, so that the number you see in front is what you want as your answer. So that's why it's C, because up here it's x minus 1. Because 1 minus 1 is 0, 1.6 to the 0 is 1, 128 times 1 is 128, and we see the 128 right here. It's a coefficient. Obviously, it's not the base. Now, so just to like expand on that a little bit, if everything was the same about this problem, but it was like f of 2 equals k, then it would just be this one down here, because it has the x minus 2, and so on. Anyways, here's how you could basically use the graphing calculator to essentially figure this one out. I mean, this is not a decimal specific thing. This is just a general, picking numbers calculator, or I guess more of a back solving approach. Basically, you're just going to type each thing. It's a little annoying. You gotta if you try to type x plus 1 in the exponent, like the plus 1 will just drop down. So you have to do the 1 first, and then you can put the x plus in front of it. All right, so here's our first one. Okay, when I evaluate that at 1, the answer is 128. And just a spoiler, the answer for all these is going to be 128, meaning that k is 128. Okay, do you see 128 as a base or constant in this answer choice? No. Okay, move on to the next one. So now it's 80, and it is just this to the x. Again, it's 128, like I said, but we don't see it anywhere in here. Now let's go to this one. Okay, again, it's 128. I do see 128 in the front. That confirms that this one is correct. And then for the last one, okay, again, the output or k is 128, but again, I don't see 128 as either a base or coefficient. So this is just an approach you could take, in Desmos just to confirm that the answer is letter C. Lastly, we have a problem involving a quadratic function and a translation of a quadratic function, and asking where it reaches its minimum. So if you actually look up this question in the question bank, because this is a repeat question, this is from one of the old tests that was retired, the explanation for this is horrendous, and it is so ridiculously complicated, so unnecessarily complicated. Now, the quickest, fastest, easiest way to do this is in Desmos, and I will show that in a little bit. I will just first mention briefly, there is a way, I mean, the way to do it by hand, which is not really that difficult, I mean, involves a little work, but not really that much, is take this function. First of all, find where its vertex is. The way we're going to do that is we're going to use the shortcut formula of negative b over 2a for h, the x coordinate. So that'd be negative 64 over 2 times 4, negative 64 over 8. So the vertex of this function happens at x equals negative 8. G is equal to this right here, which means G is equal to F shifted to the left 5 units. So negative 8 is going to the left 5 units. Therefore, for G of X, its vertex, or its, in other words, the H value, is going to be equal to negative 8 minus 5, or negative 13. So again, the correct answer for this is going to be letter A, negative 13. Do not, the approach the College Board takes is they try to put this in vertex form by first plugging in the x plus 5 to get the g of x function and doing all that algebra, and then taking that quadratic and completing the square on it to put it in vertex form. And there's no need to do that. It's just a total waste of time. All right, so let's look at the Desmos approach. So we've got our original function here. Now, at this point, you could actually just look at this and say, oh, the vertex is -8. It's f of x plus 5 as they shift to the left 5, so -8 minus 5 is going to be -13. And if you recognize that, that's fine. You click A, you're done. However, you could basically, again, have it do the entire problem for you. Meaning we type in what g of x is. Now let's take this off. Okay, for what value of x does g of x reach its minimum? Well, let's click on it right here. -13, that's our answer. Again, no need to complete the square. No need to do all that substitution, algebra work. All right, so hope you enjoyed this video, which covered the uh, answers and solutions to Digital SAT Bluebook Practice Test number 8, just released, I guess, 5 days ago now. Also, be sure to check out the solutions to Practice Test 8 Module 2A, the easier of the 2-second modules, once it is posted, and again, Practice Test 8, Module 2B, the harder of the two second modules, once that video is posted as well. Again, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And lastly, if you have any questions, comments, or alternate solution methods, please do feel free to leave them, in the comments in the video below.